Hey there, I hope you're doing well. I've got a quick video here, or we'll see how quick it is, for simplifying a square root. So whenever you have a fraction inside a square root, that fraction in there is called the argument. Anything inside a radical symbol is called an argument. And when you work with a square root, the easiest thing to do is simplify your argument as much as you possibly can. And see, I'm noticing that 448 and 900 have common factors. I know 2 divides into both of them, quite possibly 4 divides into both of them. So I want to simplify that fraction to lowest terms, and you did something similar on test 1. Also, u to the third and u squared will simplify, and v to the third and v to the 11th will simplify. So my first step is, does it have anything to do with the square root? I just want to simplify this to lowest terms. So what I'm going to do is I'm going to play with my calculator. I'm going to divide 448 by 4, and I'm going to divide 900 by 4 to simplify to lowest terms. And that may or may not be lowest terms. We'll see. So 448 divided by 4 gives me 112. Okay. And 900 divided by 4 gives me 225. Now, it's possible that there's another number that divides into both of those, but it's certainly not an even number like 2468, because that won't divide into 225. 3, I guess, could possibly go into both of them. Let me check. 3 goes into 225. Does it go into 112? No, see, it doesn't. You would think that it does, but when you add 1 plus 1 is 2 plus 2 is 4. 3 doesn't divide into 4. So I believe that fraction is as low as it'll go. When we move to the denominator, u to the third and u squared, I subtract those two to get u to the first. And that u to the first goes on top because the bigger of the two exponents is on top. I'm going to do something similar with my v's, v to the third and v to the 11th. 11 minus 3 gives me v to the 8th, but that goes in the denominator because the bigger one was in the denominator. Now my goal is to take the square root of any values that I possibly can. Now, 225, is that a perfect square? Well, if I type that in my calculator, it is. It's 15. Or you may have a list of perfect squares walking around with you as you do these problems. You've probably watched it in the video, but, perfect squares are, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, 12 squared is 144. You could keep the list going, but you need that. And it only took me about 15 seconds to do that, if that long. And so that's good to have around, although my 225 didn't land on the list, but the square root of 225 is 15. So this guy right here is a perfect square. So is v to the 8th. Anytime your exponent is an even number, that means that variable, v to the 8th in this case, is a perfect square. Whereas 112 is not on our list over here. That's not a perfect square. And u to the first, that's an odd number. So we will simplify that more in just a minute, but let's just handle the perfect squares now that we can, okay? So when I take the square root of 225, again, we said that was 15, and the square root of v to the 8th. Now, I'm not saying you take the square root of 8. When you're dealing with an exponent, it's just half of that. So the square root of v to the 8th is v to the 4th. Now, that is no longer underneath a square root because we took the square root, but the square root still is over the numerator, 112u to the first. But now I've got to focus on simplifying this 112. Question is there any number on this list over here to the right that divides evenly into 112? That's the question. So I'm going to go down the list and look to see. Now this is the time to play with your calculator because you start going down this list and you may want to start bigger rather than small. 4 does divide in 112, but you'll find out that 4 divides in there again. So 16 is your winner. So if I rewrite the square root of 112, I'm going to rewrite it as the square root of 16 times 7 times that u, and don't forget your denominator, 15v to the 4th. And then working across the page now, we know that, once again, that guy is a perfect square. So when I take the square root of 16, I'm going to bring it out front. That's 4. Square root of 16 is 4, of course. And then the 7 and the u, those are not perfect squares, so they stay underneath, divided by 15v to the 4th. And this is completely simplified. How do you know? Well, a couple of things. Your goal is to never be left with a square root in the denominator. You may not be to the section yet, but when you rationalize denominators, that handles that. So if we happen to be left with a square root down here, we would have to simplify that further. And what's underneath your square root remaining cannot have any perfect squares that are over here to the right that divide evenly into the coefficient, and you can't have any exponents over here that's higher than your root. So this is a square root right here. A little secret 2 lives right here. So there's a little 1 right here. This number can never be bigger than that number right there. And that's something that's discussed more up the road in later sections, but I thought I'd go ahead and mention it now. I hope this helps you out. Please contact me if y'all need to see any other problems or if you have any questions. I hope you have a wonderful day.